Hi, I'm Armin from Notch, and in this video I'm going to cover just some of the big changes in our recent 1.0 open beta release. I will not be able to cover everything as the jump from our previous version to 1.0 is rather big. For more details, changelogs, and in-depth information about 1.0 and how to download it yourself, check the links in the description. Notch 1.0 delivers major upgrades to the core toolset and rendering capabilities, alongside a redesigned and more user-friendly user experience. 1.0 preserves the well-established node-based workflow while enhancing every aspect of the software with powerful new features and improved functionality. Whether you're a returning user or new to Notch, let's explore some of what's new, starting with the UI overhaul and moving through the new NURA rendering system, key features, and workflow improvements. When opening up Notch 1.0, you will be met by New Launcher. From here, you can start a blank project, choose from our extensive template library, or open existing files, including projects you have created in 0.923. The launcher comes with comprehensive learning resources from guided tours to technique showcases, all regularly updated by our team and instantly available to download and use. Also new to 1.0 is that account, license, and dongle information is directly available in the launcher. Your account details and current version are visible at the top right. The Notch manual is also accessible directly from here, offering detailed documentation, video tutorials, and best practice guides for all Notch tools and workflows. Worth mentioning that right next to it you can find an option to start up Notch 923 for all your older projects. Let's start by showing you how to set up a new project. Opening a blank scene brings up our project settings panel, where you'll set some basic settings for your project and composition. Here you can set name, duration, resolution, and color space. New to 1.0 is support for ACEScg, the industry standard color space that ensures consistent color management across your projects. We've also brought the composition mode selector to the front, so you can easily choose between creating an isolated effect or a scene that integrates with other compositions. This used to be hidden in project settings and is now more readily available. To make things a bit more interesting, for the next part where we'll take a look at the major UI changes in Notch, I will close this blank composition and open one of the new samples in our launcher. Let's use the new NURA rendering sample. Alright, so let's take a look at the redesigned interface. The properties panel at the top left controls all node parameters. Note that what we previously called layers are now compositions. You can rename these by clicking the top field or pressing F5. A key improvement is custom resolutions for compositions, allowing multiple projects with different sizes and aspect ratios in the same project. The viewport has been updated to allow more direct interaction, and we've also unified the viewport controls. Use Alt left mouse button to rotate, Alt Shift left mouse button for horizontal pan, Alt-Shift right mouse button for vertical pan, and Alt-right mouse button for zoom. Previously, we had different controls when panning and zooming in the node graph, but now these are the same, so Alt-left mouse button pans and Alt-right mouse button does what you expect. Another addition to the viewport is new icons and rulers along the top and left edges. Let's take a look at these. Viewport HUD displays performance metrics and important scene stats, like how much geometry you are working with. This is handy for spotting areas for optimization. Freeze UI temporarily stops updating the UI, which is useful for more accurate performance readings and faster rendering in the viewport. Grid. Pick from the series of predefined grid sizes or make your own guides, complete with options for snapping. The viewport now also has viewport picking and placement, which is very useful for quickly picking an object or placing one in your scene. The resource panel has been completely overhauled for more efficient file handling. Key features include list and thumbnail viewing options, resource preview window, direct drag and drop support from Windows Explorer to resources, node graph, or viewport. MP4, DVX, MOV422 and animation playback is now done natively and no longer requires transcoding to Notch LC. Next on the list, PLE file type support for point clouds and PSD file support. Right next to the resource panel we have two new tabs, Assets and Material Library. Here you have access to a vast library of tools and presets produced by Notch team. Using pre-made materials and assets can significantly speed up your workflow. Of course, you are not limited to just Notch default assets and materials. You can build your own and store it locally on your machine or on a cloud-based service like Dropbox or Google Drive. Don't worry, I will cover creating assets in more detail later in this video. Next is Redesigned Timeline. As you can see, it has moved from the bottom of the screen to the middle, which makes its placement consistent as you switch between the node graph and the timeline view. Right next to the timeline is the current time indicator. Next to that is the FPS counter, where you can also choose to lock the composition to a specific frame rate or leave it unrestricted, depending on your project. Right above, that is where you find the new tabs to switch between the different views. So that's node graph, timeline, and curve editor. To the right, there's a series of tools which should be familiar to you if you used earlier versions of Notch, as well as some new additions. Let's go through those. So it's undo, redo, hide input connections, hide output connections, node link style, aligned, straight, or mixed, option to hide thumbnails, auto keying switch, freehand lasso, rectangular lasso, timeline markers, range toggle, property to make embedded node instanceable, and an option to create a new asset from nodes. Both of these options we will cover later in the video. Now let's look at the node graph. There are many new tools and changes here, from the brand new node design to the way you connect nodes. In 1.0, you can now parent on the left-hand side, and you can link nodes in both directions. You will notice that the look of each node is more uniform. Kept from the previous version is the color coding of different node groups, which makes them easy to separate. But now they are accompanied by descriptive icons as well. These icons are now consistently used whenever a node is seen in the UI. Some node groups got new colors, and several nodes were deprecated and replaced with new, improved versions. I'll cover those later on in the video. As you can see, you can expand and minimize the node list, and you can see all your compositions on the left-hand side. Being able to minimize panels is convenient for saving screen real estate, especially on lower resolution screens and laptops. Let's add a couple of nodes to the scene. Let's use the new floating node search, which we can access by pressing Ctrl space. This is handy for quickly adding nodes to your scene wherever your mouse cursor hovers. The floating node search lets you pick from all available nodes, and also a new type of a node called clusters. Clusters are pre-made sets of connected nodes. Think of them as presets for sets of nodes you use often, or even properties on nodes. For example, let's look at 3D primitive. The default mode of this node is a sphere. If I instead wanted a torus, I can simply use the float search, type in torus, and it knows I want a 3D primitive set to the torus type. 1.0 comes with many of these clusters already set up, with more to come in the future updates. Another great addition to the node graph is node hints. Hints are suggested nodes and connections based on which nodes you add. Let's look at the example using Skylight node. Once I add this node, notice the gray outlines of possibly related nodes showing up. Once I click on it, it adds the node and its connections, which is very handy. We developed this to help new users, but it's actually shown to be very useful even for long-term Notch users. You can ignore the node hints by clicking anywhere in the empty node graph, or if you clicked away but you want a suggestion of the hint to come back, just double-click on the output of the node. Let's add a material to our torus and create some copies. If I want to maintain the material link across all my new nodes, I'll use Ctrl-C and then Ctrl-Shift-V. This preserves the material connection for all pasted objects. Alternatively, I can hold Shift while connecting the same node to multiple inputs, which is another time savior. For even more efficiency, holding Ctrl lets you insert a node in an existing connection. With all these nodes in our graph, things can get messy quickly. Fortunately, the node arrangement tool gives us 3 layout options plus a spacing handle to organize everything to your liking. If you're looking for a specific node in a complex graph, the updated search function is invaluable. Just press Ctrl F to find and navigate to any node. Another quality of life improvement is the bridge node, which allows you to connect distant nodes without drawing long, cluttered links across a graph. While we're working with primitives, it's worth mentioning that Notch 1.0 now supports custom pivot points. This applies to both Notch primitives and any imported 3D scenes. You'll find this option under the pivot point section in the node properties. The 3D scene node has received significant updates as well. Notch 1.0 handles large geometry counts with ease, and you can now break out sections of your 3D scene into separate nodes, allowing you to delete or modify specific elements. This is extremely useful when working with kit bashes or complex imported scenes containing numerous small details. Video processing workflows have gained some excellent features too. You can now picture-in-picture your video in the viewport, and you can always verify whether you're looking at a full composition or a specific chain by toggling the preview button at the top of the viewport. The currently active preview node displays a small icon next to it in the node graph, which applies to any multi-choice nodes from cameras to renderers. Speaking of video processing, we've added several powerful new tools like Kuwahara filter, histogram threshold, which can be used to better control live camera effects. Pixel sorting now has a mask input. We have a new physical glow node for more realistic glows, and physical lens flare. There are many more useful features to explore in the node graph, but let's move on for now and return to these when we look at more complex scenes. Finally, turning to the node list, you will see that the same icons and color coding from the floating node search can also be found here. We've also added a favorites section where you can bookmark any frequently used nodes for quick access. So far, we looked at the main user interface and some of the many changes that have been made to the part of Notch you might already know. So let's move on to take a look at some of the new panels and tools. Starting at the top, we have 3 new tabs. Create, this is where we're at now. Inspect and render. Inspect opens the new resource inspector. This is a brand new addition to 1.0 and lets you make changes to imported resources in a much more convenient way than before. Previously, you would have had to do a lot of these changes in a separate tool or during import, but we've gathered many of the common actions here, so you no longer have to. Among the many things you can do, I'll mention some of my favorites. You can now easily flip and scale resources. It's not uncommon for 3D files to be in wildly different scales and orientations, so this makes it easy to bring a variety of files from different sources and have them uniformly scaled or oriented. You can now choose whether or not to embed the resource inside your project file or leave it as an external reference instead. Technical details such as polygon and triangle count can now easily be seen when inspecting 3D resources, making it easier to make optimization decisions early on in the design process. When importing full 3D scenes, you can now flatten them down to make them much more efficient to work within Notch. And lastly, Resource Browser isn't just for 3D files, but works for images and video too. You can flip, rotate, and scale, as well as trim video and audio clips. You can access Resource Inspector from this tab, or you can click on the magnifying glass icon in the Resource Browser. Next, let's look at the new Render tab. This panel has been designed for both video and still image rendering in mind. All of the most common render settings like range, output format, and resolution can be found here. And you can choose to immediately start a render or send it to the new render queue. It's also worth mentioning that we've added native H.265 video rendering and completely rewritten the tiled rendering option, which makes it possible to render large resolution video on a GPUs with lower amount of VRAM. The new render queue is accessible by going to View, Render. I'll add a few copies of my scene in here now so you can see how it works. You can reorder and make changes to each render in the queue from here. And I'll just quickly mention that you can also drag compositions directly from the timeline view into the render queue as well, which is very useful. Expose parameters is a well-known thing in Notch whereby you expose a set of parameters to a media server, and you can then use those parameters to live control the rendering of your Notch scene in the media server. New to 1.0 is that we've made expose parameters available in the render queue. This makes it incredibly easy to quickly make variations on your rendered scenes, like exposing text or color and then rendering out many files without having to manually modify your scenes each time. Next, let's look at the improved timeline view. We can switch to this by selecting the timeline tab. First off, what used to be called layers are now called compositions, and this more accurately reflects what they actually are. By default, timeline is not showing anything, and that's actually by design, as previously this view would get really busy with many elements when all nodes' timeline properties were shown at the same time. First off, we have the option to just show selected nodes. This is very handy when you're working in the node graph and quickly want to jump to the timeline to adjust something. If I make any changes to the timing of these nodes, or if I keyframe them, they become permanently visible in the timeline. To build on this and have even more granular control of your node visibility, you can use pinning. Using this button here or keyboard shortcut P, we can pin the nodes we want to always be visible in the timeline. This is useful when you have certain nodes you always need to adjust. And of course, you have a choice to see all nodes in the scene by toggling this icon here, show selected or pinned nodes only. Let's take a closer look at one of the nodes represented in the timeline and use it to showcase another welcome change, segments. The new segment tool allows you to split things into segments and trim them. Use the keyboard shortcut C to enable the cut tool, or activate it by pressing on this icon here. Segments are great for controlling the visibility of certain elements in the viewport or render without making multiple copies or instances of the same node, essentially giving you the power to cut and trim visibility over time. In the same menu panel, we have the transform tool, which allows you to select, copy, paste, and move multiple keyframes at once. You can of course multi-select by dragging and selecting with the cursor, but the good thing about transform tool is that it maintains internal timing and scale among the selected keyframes, letting you easily tweak the timing and scale of your keyframed animations. When it comes to keyframes, we've redesigned how they are displayed as well. The topmost view shows you if there are any keyframes at all associated with a selected node. If you click on this drop-down icon here, you can see which properties are keyframed. The innermost view shows you a handy set of mini curves for quick tweaking of animations without going to the curves view, which is handy for making fast changes. On the topic of curves, let's take a look at completely redesigned curves view. This is the view that gives you tremendous control over your animation, and in 1.0 we made this much easier to use. A classic issue when working with curves is when you animate properties of wildly different scales. In the previous version, this could be problematic and hard to work with. The new overlay view in 1.0 allows you to see keyframes from multiple scales in one coherent view. This is done by separating each curve first by their individual scale, and then rescaling them visually to fit within the same area. This allows you to see and manipulate all your curve animations in one screen, even if one property goes from 0 to 1000 and another goes from 0 to 1. Another improvement is 2 manipulation handles for the curves. Now you can grab keyframes in your curves from either side of the keyframe, compared to before when it could be hard to select and manipulate. Next up is the transform tool. This allows you to adjust timing and scale of the keyframe animations. Simply drag a region around the keys you want to adjust and adjust the box to retime or scale them as a group. Very handy. We've now made sure that X, Y, and Z curves are colored to represent the different axes. Previously, they were all the same color, making it harder than necessary to find the right one. Let's round off the look at the major UI changes by mentioning some new panels and features in Notch UI. The UI system has been completely rewritten, and one of the benefits of that is that you now have much more control on how you want to arrange the windows and panels in Notch. All the panels can be moved and docked to make your workspace just how you like it. Let's look at the remote. Here you can change and interact with all of the exposed parameters, which makes it practical when setting up an exported block for a media server use or while preparing for an interactive installation or a live show. Another place we've cleaned up is the new settings panel, where you can find the most important settings and preferences in one place. The panel is now much cleaner, easier to use, and offers more settings in a single screen, where previously these settings were distributed between the main Notch settings screen, the project settings panel, and the preference panel. A nice housekeeping feature is the new native color scope panel, which lets you monitor your luminance, histogram, and color parade as you work. You can also flip between overlaid and split views. And on the topic of standalone, we know that many users really like the old Web GUI, and good news, in 1.0 the Web GUI has been completely rewritten to be much more convenient and useful. You can now arrange exposed parameters in columns, and the Web GUI can handle a wider range of exposed parameters which previously could be tricky to work with. Let's talk about rendering in Notch, which has undergone one of the biggest transformations in version 1.0. The team has simplified and unified rendering across the board, allowing you to switch from real-time to high-end rendering with just a single node change. No need to adjust materials or lighting settings. Let's take a closer look. Notch now offers 4 rendering options, all of which are accessible as nodes in the node graph, making them easy to switch between. So here we have Standard, Hybrid, Smart Tracer, Path Tracer. These 4 renderers form what we call NURA, the Notch Unified Rendering Architecture. The key advantage is that you can seamlessly switch between these unified renderers while maintaining consistent results without changing your materials, lighting, or render settings. It's easy to imagine the impact this can have on your workflow when it's possible to go from super fast real-time rendering to perfect path tracing and back again. In many traditional 3D applications or game engines, you are often forced to make a choice of renderer early in your project, which means you build and tweak your materials, lighting, and even mesh complexity to suit a specific renderer. Attempting to switch renderers later on can be a challenge. Let's take a closer look at each of 4 renderers and what you can expect from them. Path Tracer. This is our native GPU-powered path tracer, the gold standard for graphics rendering when you have the time to wait for great results, and the reference for others, more speed-focused renderers that I'll cover in a bit. Path Tracer is our GPU-native, Monte Carlo-based refining path tracer. It delivers the most accurate and high-fidelity results using unbiased rendering algorithms while remaining fully interactive in the viewport. Beyond lighting, it physically samples anti-aliasing, depth of field, and motion blur for the most accurate results. It handles not just polygons but also fields, particles, and procedurals. Everything interacts naturally without special cases. While it's our reference renderer, it does not compromise on speed or scalability. It utilizes our own GPU optimizations and the latest sampling techniques to minimize required refinements, and incorporates AI denoising from NVIDIA and Intel. You'll use Path Tracer when you need a highest fidelity renderer or when you require massive scalability and determinism is critical. Next, we have the Smart Tracer. This is essentially our path tracer with a speed boost, bringing new levels of interactivity and performance using the latest GPU-based ray tracing acceleration algorithms. The Smart Tracer is built on cutting-edge ray tracing research. It uses many of the same lighting calculations as Path Tracer, but accelerates them using spatiotemporal path guiding and reuse of raster. This dramatically reduces the number of passes required for a final quality render, from thousands to tens, or even just 1 in some cases. The Smart Tracer is ideal for projects where clients need high quality rendering but lack time or budget for pure path tracing, or achieving a near final rendering quality while maintaining interactive frame rates, or scenes with many lights and complex geometry. It's also very handy when working with tiled real-time rendering or high-end multi-GPU setups. Next is Hybrid Renderer. This combines high-speed rasterized rendering with ray tracing features, quality, and scalability. GPU rendering is currently at the inflection point, transitioning from rasterized or pixel-based to ray trace rendering. The Hybrid Renderer takes the best of rasterization techniques and enhances them with ray tracing. Real-time projects need speed as well as flexibility and responsiveness. This renderer offers options ranging from fast real-time all the way to high-quality offline rendering. The included race mode, for example, lets you handle polygon counts into the billions. You'll want to use the Hybrid Renderer when you need features the standard renderer can't provide, or when you're scaling across multiple machines or GPUs. Standard Renderer. This uses classic real-time rendering techniques to provide the fastest possible rendering with a solid set of artistic features. It fully supports Notch materials and shader graph, offers a complete range of light types, and includes a streamlined set of effects to ensure real-time frame rates with instant response. It's great for real-time, show critical 3D, as well as high-end 2D work. You'll want to use Standard Renderer to work on things like video effects, interactive installations on a single GPU, lower polygon counts, and projects where you don't have access to high-end GPUs, either while working or when deploying to a media server. In addition to the massive rendering overhaul, it's worth mentioning that we've also made updates to a whole range of third-party SDKs that supports things like 3D file formats and rendering-related features like the new Intel Denoiser, which now runs on GPU, just like NVIDIA Optics, which has also been updated with this release. Moving on from rendering, let's talk about improvements to node organization with the introduction of embedding nodes and assets. Embedded nodes allows you to group multiple nodes together in a single node, which helps keep your node graph neat and is also first step in creating an asset. Let's look at an example. I'll create a basic embed with a null as a parent and a couple of primitives as children. Now I can grab these child nodes and move them inside the parent node, which is all it takes to create an embedded node. Notice that when I enter the embedded node, the rest of the node graph darkens to indicate that now I am inside embedded node and can only see the internal node graph. Here you'll see an automatically generated new node called exposed embed. This node is crucial as it allows us to expose inputs and outputs that will be accessible from the parent node when we collapse the embedded node. Let's go to one of the primitives and expose a property. You'll see the small triangle dialog when I click it and select Expose to Asset. This property becomes available both in the exposed embed and in the parent null. Let's return to the embedded node and expose a few more parameters. On the second primitive, I'll expose a color property. You can see how this now also appears in the exposed embed node. Notice that I can reorder these exposed properties, rename them, and even group them if needed. Before we go out of the embedded node graph, let's expose one more thing, not a parameter, but an input. I can do this by connecting the output of exposed embed to, say, the first primitive's material input. You'll see a new input pin appear on the parent null. I've effectively created an exposed input for this primitive that's now accessible from the outside of the embedded node. So far, we've created a simple embedded node and exposed some parameters and an input. That's nice in and of itself, but when this gets really powerful is with instancing. I can take this embedded node and make it instanceable. I can do that by right-clicking and selecting this option. Now, when I copy and paste this embedded node, you'll see that the exposed parameters are unique, allowing me to create variations. However, I can still go into the embedded node and change parameters there. And those changes are inherited by all instances. This way you have the best of both worlds, central control and individual tweaks to instances of the embedded node. Now let's move on to assets. Assets are fundamental to Notch 1.0. Typically, they are embedded node systems saved with custom parameters that let you easily adjust the internal systems from a simplified view. This means you can create complex effects with many interconnected systems under the hood, resulting in a much cleaner node graph as it looks like just one single node. Additionally, assets can be saved to your local or network drives, along with any resources used within them. This makes sharing assets between teams and across projects easy. Internally, the art team at Notch actually uses a cloud folder for all the assets we build, meaning someone who is really good at making assets can share those with the team, and someone else who is perhaps stronger at 3D or composition can use those assets in their projects. If you have already installed and tried Notch 1.0, you've seen that we've bundled the install with a large amount of free assets that you're welcome to look at, copy, explore, and learn from. You can find those in the assets panel. Alright, so to round this chapter of the video, let's look at how you can create an asset out of embedded node. It's really simple. Select the embedded node and click the menu item Create Asset from Node, or right-click and select Create Asset. Be sure to give it a meaningful name, add a description, and include any other relevant information. Then choose where to save it. I'll put mine on the desktop, but you can place it anywhere on your hard drive or use the default path in Documents, Notch Assets. Once saved on my desktop, I can bring this asset into Resources and use it in this project or any future project. If you use the default path, your newly created asset will appear in the Asset tab under My Assets. Alternatively, you can go to Edit, Preferences, Assets, to set your own custom path for where you want to keep your assets, like on a cloud folder like Dropbox or Google Drive. Finally, let's quickly mention material assets. Native Notch materials are actually assets too. We've separated them in our asset libraries because it's useful to have materials listed separately from other assets. But you can certainly save materials with the general asset list as well. ON materials can now be previewed in a viewport, just like you're used to from the other resource type. So far, we looked at the assets and embeds, where we touched on exposing parameters. Now let's examine all the options available for the different types of exposed parameters and where they can be used. Most parameters in Notch can be exposed. What this means is that the property is turned into an editable variable that can be controlled from outside of Notch, like from a media server, a light desk, the new web GUI, or even directly via OSC. A clear indicator of exposable parameter is the drop-down icon in the Properties panel. As I hover, I can see all the parameters that can be exposed for external use. Please note that not every single parameter or setting in your project can be exposed, either because they are static to the scene or for other reasons that makes them ill-equipped to be changed externally. Let's click on one and check what options we have. Notch block, Artnet, render queue, VFX block. I'll come back to the last one a little later as it's an upcoming feature, but let's take a closer look at the first three options. Notch block. You might be already familiar with this workflow from earlier versions of Notch. This allows you to expose and manipulate various parameters via media server or standalone application. When I expose a parameter, a new node appears in the node graph that looks similar to the asset node, but with additional options. For example, scope. Scope allows me to see exposed parameters in this specific composition or all exposed parameters across the entire project file. Quickly coming back to something we covered in an earlier part of this video, the new remote panel is a great place to see all your exposed properties for media server use and try manipulating them directly. Moving on to Artnet, while you could expose properties to Artnet in the earlier version of Notch, it has now been given its own separate section. You can see all exposed parameters and DMX offsets directly in a dedicated node. Notice the color change in the exposed node. Different colors are associated with different types of exposed nodes. Next on our list is using exposed properties with the new render queue. This is extremely convenient when you want to render out multiple variations of the same still or video. This can be things like color, text, meshes, or even render properties like amount of render passes, anti-aliasing options, etc. Now, instead of going into the node graph and changing all of these properties in different places, making copies of your compositions and making your project file all messy, you can simply expose the properties to render queue, set desired variables, and render everything at once. This is an incredibly practical, time-saving feature in 1.0, and I use it all the time. And finally, let's talk about VFX blocks. We're currently working on a new export option which will allow you to run your Notch content in offline rendering tools like Adobe After Effects. Here, exposed properties play an extended role since you will be able to render any Notch content using all NURA renderers, by the way, inside of After Effects. We have been working with some big name motion design studios to develop this feature, and we're really excited for what it can mean for your existing rendering pipeline when the feature ships later this year. Alright, from the exposed properties, let's move on to talk about deformers. Deformers are a key ingredient in Notch and are extremely powerful tools to modify geometry. In 1.0, we've rewritten, optimized, and improved all of the existing deformers, as well as added a whole slew of new ones. We've also updated our manual with a whole new section that showcases all of the deformers and how to use them, which I recommend to take a look at. For this video though, I'll only cover a couple of the new and improved deformers. First, you'll notice that the deformers are now subgrouped by properties in the node list, making them much easier to find and navigate. This organization helps you quickly locate the specific type of deformer you need for your project. Before we add any deformers, let me highlight a practical new node that works perfectly with them: duplicate geometry. This node allows me to create instances of the original geometry that I can then process with different deformers in separate chains. Think of it as similar to a video null when processing video. Here I have an imported FBX model with some animations. Using a duplicate geometry node, I'll create several instances. I'll then hide the original model, and then start adding some creative deformer variations to each instance. Let's try the Greeble deformer first. This classic 3D effect has been around for a long time, but it's incredibly versatile and can be used for many cool things. We can adjust these parameters to control how it generates surface detail. Now let's apply a weight map to this processing chain. Weight maps have been completely retooled in 1.0 and work with many more deformers and other nodes. Notice that we have many more options now for weight map generation. I'll use null to weight map and connect it to the skeleton of this mesh. Then I'll use weight map to drive the Greeble position and visibility. Moving on to the next instance, let's apply the line splines deformer, one of my favorites. You can create some really interesting designs with this. We can complete this with a retopologized deformer for even more interesting results, like so. For our final chain, let's try breaking things up. The Voronoi shatter deformer is another classic effect used for shattering 3D meshes. Let's apply it to our instance 3D mesh. As you can see, we can specify the number of Voronoi points, change the seed value, select different modes, and even color the fragments for easy preview in a viewport. Now I'll jump to the next composition to show some of these new deformers in action, in pre-made scenes that can better illustrate what you can do by stacking these relatively simple deformers. We've also added two brand new physics-based deformers for simulating cloth and rope. These have the important advantage of not actually needing the physics root node, which is convenient for quick setups. While playing with the simulation, let me highlight the major improvements in the new cloth deformer compared to the previous options we had. First and most notably, we now have self-collision of the cloth, which you can see happening in this simulation. The node also now has proper friction and bounciness handling, making the cloth behave much more realistically. Of course, it's possible to make it behave completely unrealistically too. It's very much up to you what you want to do with it. Alongside these improvements, rigid body force effectors now work seamlessly with cloth simulation, and collisions are significantly more advanced as they properly propagate the velocity of the collider. Alongside these improvements, rigid body force effectors now work seamlessly with cloth simulations, and collisions are significantly more advanced as they properly propagate the velocity of the collider. This means when objects interact with your cloth, the resulting movement looks far more natural. All these enhancements apply to the new rope deformer as well, with a few additional features unique to this node. In the rope deformer, you can use constraints to anchor specific vertices, the first, second, or last, as you can see in this example. This is extremely useful when setting up your rope simulations. Similar constraints features are planned for the cloth deformer in the future updates, but you can already achieve similar results by using weight maps. These physics-based deformers represent a significant step forward in creating realistic simulations while maintaining the flexibility and ease of use that Notch is known for. Let's talk a bit about physics in Notch 1.0. The physics simulation have received significant improvements in accuracy, performance, and general workflow. Large-scale collision simulations now work much more reliably, especially with the scenes which have large quantity of objects in varying mass and friction properties. Performance has increased across the board compared to version 9.23, and a particularly annoying limitation in the previous version where no more than 5 dynamic bodies in a scene at once no longer exist. There has also been a substantial update to the popular cloner rigid body effector. The rewritten effector now lets you use tens of thousands of instances in your scene. This is a huge leap forward in creating complex physics-based installations and effects. Another valuable new feature is the propagation of kinematic collider velocity for dynamic physics objects. This makes simulations much more physically accurate and dynamic than before, as one object direction, speed, and mass can be propagated to other objects through collisions. The simulation is also much more stable than before. It's worth mentioning that physics and simulations are being actively developed, so you can expect more exciting features in upcoming releases. Let's talk about splines. While spline tools existed in the previous versions, 1.0 features a completely redesigned and much more user-friendly spline node. One of the most significant improvements is the ability to paint and edit points directly in the viewport. The Spline tool now offers more flexible tangent controls with several options: auto, align, broken, and mirrored, helping you precisely dial in your desired spline shape. For quicker workflows, the Spline tool features a quick access menu. This menu mirrors all of the options found in the Properties panel. This particular addition significantly speeds up your work when creating and modifying splines. It's worth noting that splines can be used in both 3D and 2D. For 2D use, simply use the 2D route. Having the spline tools available in 2D workflows makes it a versatile tool for all sorts of motion design alongside traditional 3D workflows. As you can see, the new spline system offers a highly customizable, precise way to paint and use spline curves for all sorts of design tasks. Fields got a significant overhaul. Fundamental top-level change from 9.23 is that simulation was a uniform grid and now it is a sparse grid. So basically this bound box is split to uniform voxel cells. All smoke sims works this way, but the difference in 1.0 is that we store active cells only where there is something actually simulating. Let's talk about the major improvements to fields in 1.0. Fields are used to simulate things like fluids, smoke, fire, as well as more creative visualizations. In technical terms, field simulations have changed from using a uniform grid to a sparse grid. This smart use of resources brings three key benefits. First, you can create much more detailed simulations with finer wisps of smoke or more realistic fluid movement. Second, these higher quality simulations run faster than before. And third, you can work with larger simulation spaces without performance issues. This improvement also removes some of the technical barriers, giving you more creative freedom to achieve the visual effect you're aiming for, spending less time on simulating or rendering. One area where this becomes clear is that you no longer have to specify the voxel grid resolution, and you can use a bounding box that uses real-world units. You can of course override this if you want, but for the most, this change makes it easier and faster to work with fields. This can feel a bit abstract, so I want to show you what this used to look like and what it looks like in 1.0. Here we are in 9.23, and as you can see, when I increase the size of the bound box, the size of the voxels inside scale up as well. So here we just end up with a bigger box, but not more detailed simulation. Now let's look at how it works in 1.0. Here you can see we have two new properties: bound size, which is the total area, and voxel size, the size of the voxels, or in other words, how detailed the underlying simulation is. 1.0 will use these properties to calculate the resolution dynamically under the hood. In 9.23, fields could be tricky to work with, as it was pretty easy to get things wrong, especially when using a non-cubic bounding box, where an aspect ratio of your sim would be way off, leading to stretched voxels. In 1.0, you don't have to think about this anymore. On the topic of simulations, it's worth mentioning that the new simulations are more physically accurate in 1.0, so you'd no longer have to add a bunch of effectors to get something that looks correct. We've actually collected many of the common parameters directly in a field route and in the renderers to keep things easy and accessible. Fields is one of my favorite features, and I could spend hours talking about each and every parameter. But for now, I'll end this section off with the video by mentioning that fields in 1.0 work across all the NURA renderers and all the lighting options. Previously, there were major differences that made fields unusable with some renderers, but that's no longer the case. Here are just a few things myself and Notch team have created using the new fields in 1.0. As you can see, since every system in Notch is able to connect to every other system, you can create some very interesting things. Particles can become fields, or fields can become meshes, and meshes can be procedurals. You can really go nuts with this. And on the topic of procedurals, they have been completely rewritten in 1.0 and are now way more performant and produce better looking results than ever before. One great new addition is the procedural ray tracer. Using this, you massively improve the level of fidelity at no additional rendering cost compared to the procedural meshing, which can introduce performance overhead. The procedural ray tracer is also not bound by a bounding box, so you can use it to create massive scale worlds and scenes. Just like with fields, procedurals have been updated to work across the board with all the NURA renderers, so you can use them with path tracing or with fast standard renderer without changing any settings. One cool thing we've included is the fractal node. that generates fractal shapes that can be used directly with the procedural ray tracer. Personally, I love the look of fractals, and when combined with typical procedural Boolean functions, you can make some really cool stuff. From procedurals to cloning. The cloner node has undergone a significant transformation in 1.0. The functionality we know from previous versions has been split into several dedicated nodes to make it more accessible. Instead of a single cloner node, we now have 3 additional, clearly named nodes that do exactly what their names imply. Iterative cloner iteratively applies a transform to each new clone level so that the new clone offsets from the previous one. This can create spirals and fractal-like effects where clones appear to grow out from a central point. Grid cloner positions clones on a grid where you can define the spacing and resolution. Radial cloner positions clones in circular patterns and directions, great for making repeating and tiling cloner effects. Along with this restructuring, we've added a new linear cloner, which creates clones in a straight line pattern, a simple but incredibly useful addition. A brand new addition to the cloning toolset in Notch is the Clone Painter. This powerful feature allows you to place or paint clones directly onto 3D objects. It comes with a wide range of options for precise and creative control over both appearance and placement of your clones. Similar to the Spline tool, Paint Clones includes a viewport menu bar for easy access to its controls. The cloner effectors have received updates as well. A new function added across all cloner effectors is the selection mode, which lets you select clones by ID. This gives you options like index, range, step, and random in range, providing much more control over which clones are affected. The color ramp effector now supports color blend modes, which is one of my personal favorite quality of life improvements. You can now stack multiple color ramp effectors to create more complex color variations across your cloners. And of course, it's important to mention that we've implemented one of the most frequently requested community features, the ability to clone lights. This opens up exciting new possibilities for creating dynamic lighting effects in your scenes. Let's discuss the shading tools in 1.0, which have been completely overhauled. The new shading tools are no longer bound by resolution or animation pattern presets, which allow for much more flexibility and control. Notch now includes a comprehensive set of new shading tools that help you set up and fine-tune your materials. You can use fractal noise or gradients independently or combine them to create interesting and complex outcomes. And additional noise and warp types can be used to add sophistication to your materials or shading. With the shading tools, you can procedurally generate images to use for textures. You can generate UVs, normals, and weightmaps. You can even use them as inputs for field materials, which is really cool. In a previous version, shader nodes were fairly limited, but in 1.0, they can be used across the entire tool. This expanded shader functionality represents a significant step forward. And looking ahead, we're adding even more shader options that can be used in even more places. Along with the code changes for the shader nodes, we've also updated our documentation, and I strongly recommend that you take a look at it and see just how flexible the new shader system is compared to the old one. Link is in the description. Let's take a look at 2D Root, which is new in 1.0 and lets you create 2D graphics directly in a viewport, using a self-contained rendering system with its own resolution settings, anti-aliasing, and blend modes. This node lets you create and render high-resolution 2D content at incredible speeds. Like the rest of Notch, the 2D Root considers the node hierarchy, so elements are processed and rendered accordingly, and you can easily control the order of operations by rearranging them in the node graph. Though it has 2D in its name, the 2D Root isn't actually limited to 2D nodes. All of your 3D scenes and content work just as you would expect, so you can use geometry, particles, and everything else you would in any other scene. You can use the new viewport guides and snapping to make pixel-perfect renders that include video, text, or any other native Notch generators. And you can work in either normalized coordinate space or pixel coordinates, giving you the flexibility to use 2D Root for a variety of uses, including traditional full-screen motion graphics or something like futuristic HUDs or glitch effects. You can also use 2D Root as a basis for generating materials that can be easily mapped to 3D geometry. Not really related to the 2D Root, but since a lot of people use text in 2D designs, it's worth mentioning that the default text node has gotten some small but nice updates too. For one, you no longer need to add TrueType or OpenType font before you can see your text, though You can of course use whatever font file you want. And Notch now handles Unicode fonts much better than in previous versions, which is great for international character sets. Another area that has gotten some nice improvements is audio reactivity. Sound is a critical element for many Notch projects, and the new Sound FFT modifier allows you not just to see real-time FFT visualization of the audio signal, but to visually draw regions where the modifier should react. What's even cooler is that you can use this in combination with the added sound region modifier to specify as many regions as you need, giving you much greater control over how your visuals respond to specific frequencies. Both the new sound modifier and the classic sound modifier now supports enhanced ways to handle incoming audio, including mid-side processing. This means you can have your sound modifier react to either the full stereo signal or isolate just the mid or side signals. This opens up exciting new possibilities for creating more nuanced audio reactive content that responds differently to mono versus spatial audio elements. Audio analysis overall has been improved with the addition of peak normalization of the combined audio signals rather than peak per channel, which ensures more consistent channel levels. When using sound files with your project, waveforms are now clipped to the Play Sound node's timebar, which makes it easier to keep track of sound position within project. And waveforms are now visualized when viewing sound files in the resource browser, as well as listing the duration, sample rate, and number of channels. And last but not least, we also added a mute button on the timeline ruler, which does exactly what you think it does. Now let's take a look at what's new with particles, one of the most popular tools in Notch. This system has received several substantial updates in 1.0. And the first thing I'd like to talk about is the ability to render particles as 3D geometry. Let's open this scene I've created where we can take a look at the particle to point geometry node. This node creates a ray trace sphere for each particle. While it's not geometry in a traditional sense like primitive, these spheres correctly simulate lighting and material shading just like 3D object. And you can add a material node for greater control. The major advantage of using ray tracing is that you can use much larger numbers of particles in your 3D setups without introducing significant GPU performance costs. In this example, I'm running million particles while still maintaining real-time frame rates, which is really cool. Moving on to the next example, the line connection renderer creates lines between pairs of nearby particles, giving the impression of mesh-like structure. A great addition to this node is the option to render these lines as 3D geometry. Next is the softball renderer, which allows you to render particles as approximated soft bodies that interact with each other. One cool way to use this is to have them interact with scene geometry through collision nodes, whether using primitive or mesh collision. Speaking of collisions, all particle collision nodes have been updated for better precision and accuracy. A standout addition to the available options is the particle-to-particle collision node. This allows particles to collide with each other during simulation using a different collision radius. When combined with particle-to-particle geometry node and a similar collision radius sphere size, you can create simple systems that spawn very complex and very visually appealing interactions between particles. One big thing to mention is all the work that has gone into rewriting the particle simulations to be deterministic. Determinism is important when you want your particles' movement and position consistent every time you play back your scene, and it's vital for things like multi-screen or multi-server setups for LED walls, where you want the particle to flow naturally between them and not pop and move randomly. Significant work has also been done to improve performance across the board, especially for the large or high-resolution particle scenes. And it has already been used on huge dome shows like Sphere in Las Vegas. That brings us to the end of this overview of just some of the changes and improvements that Notch 1.0 brings. Whether you're creating real-time visuals for live events, designing interactive installations, or producing high-end rendered content, the massive 1.0 update gives you the tools to bring your creative vision to life with unprecedented flexibility and performance. Thanks for watching, and I can't wait to see what you create.